In this demo, we'll make sure we can create a point of interest for a city through the repository. Let's uncomment this post action. And let's have a look. It accepts a point of interest for creation DTO. We'll have to map this to a point of interest entity. So let's create a mapping in our point of interest profile. We know how to do that by now. Now, if we have a look at the point of interest entity and put it next to the point of interest for creation DTO, we can see that it has more properties than the DTO. But that's no issue for the mapping, because as we learned, AutoMapper will ignore these. Back to our controller. We're calling into the in-memory data store here to check if the city exists. We can now replace that with a call into our repository method. So we check if the city exists by calling into cityExistsAsync. We have to await that method. That means that our action has to be marked with the async modifier and has to return a task. What we also previously did was include an ugly and not completely safe count to get an ID. That can now be removed as the primary key column, ID, is auto-generated. And the mapping can be replaced with a mapper.map statement. So, to get to our final point of interest, we map the incoming point of interest for creation DTO to a point of interest entity. And we can get rid of this. Now we need to add this point of interest. We can no longer just add it to the points of interest for the city because we don't have a city entity at this level anymore. We replaced getting the city with a cityExistsAsync call. So we can get rid of this. But we do have to add an additional method to our repository now. Let's open the repository contract, and we add one method. The method should accept the point of interest entity we want to add and the city ID, as we need to add it for a specific city. It's also important that we add these types of methods to the repository, because we want to keep our persisted related code contained there. Alright, so we added it to the repository contract. Now let's implement it. In this method, we fetch the city. We've got a method on the repository for that, getCityAsync, so we use that. We don't need to load the points of interest as we're simply adding a new one. So include points of interest can be false. And then we add the point of interest to its collection of points of interest. That will make sure that the foreign key is set to the city ID when persisting. Now, this statement doesn't effectively persist the point of interest yet. The add method adds it on the object context, i.e. the in-memory representation of our objects, but not yet in the database. That's also why this call isn't async. I'm not using addAsync here because this is not an I/O call. It doesn't go to the database. To effectively persist everything, we need to call saveChangesAsync on the context. So that's another method we'll need on the repository contract. Let's switch back to that repository contract, and we add a method, saveChangesAsync. In the implementation, we can then implement it. The call into saveChangesAsync returns the amount of entities that have been changed. We want our method to be true when 0 or more entities have successfully been saved. In some implementations, you might only want to return true when 1 or more items have successfully been changed. But for demo purposes, we're going to be a bit forgiving here. So that's it for the repository. Back to the controller. We can now call these two methods. First, we add the point of interest for a city, and then we save the changes. If something goes wrong here, something went wrong at server side. That means that the framework will automatically return a 500 internal server error. If the save went well, we want to return that saved point of interest with a 201 created status code. The nice thing is that from the moment on saveChangesAsync has been called, our entity will have its ID filled out, auto-generated at database level. So all that's left to do is map the entity back to a DTO and return it. So the point of interest ID is the created point of interest to returns ID. And we include that in the response body. That's quite a lot of code to run through. And it's the first time we're persisting through Entity Framework Core. So let's set a few breakpoints and give this a try. Let's set one here. Let's set one right after the mapping. And let's set one after having persisted the changes. The request to send is one we've sent before. We're adding a new point of interest to Paris. Let's send the request. And we hit our breakpoint. So far, so good. Let's have a look at the incoming point of interest. That is indeed a point of interest for creation DTO with the two values from our request body. Now let's see what happens to it after it's been mapped. And there we go. We now have a point of interest entity that contains the values that were inputted via the DTO. As you can see, city ID, city and ID are not filled out yet, so this definitely hasn't been persisted yet. And then we persist it. Now let's again have a look at that final point of interest. It should now indeed be final, which means that it should now contain foreign keys and an ID. And that is indeed the case. It has a foreign key, city ID, the related city is in there as well, and it also got an ID. It has effectively been persisted. And then that entity, our now final point of interest, is mapped back to a DTO and returned. We should see the effect of that in the response body. And here it is indeed, with the ID in place. Let's fetch that point of interest just to check. As we remember, we can get the location via the location header on the response. So we send the GET request. And there we go, Père Lachaise. On to the next demo, where we'll learn the required steps to add update functionality through our repository.